We're going to talk about section 2.2, which is about friction, and you need to know the concept of normal force before we begin. We'll talk about the friction coefficient in a couple minutes. But normal force is actually the force that opposes the gravitational force. We did talk about that a little bit last class. A lot of you weren't there, but so if we have, let's say, a wooden floor, and there's a block, there is a gravitational force pulling down, and we already talked about it. I'm going to call it F sub g, and that's equal to mass times gravity. Okay, and now to find friction, I'm going to call this F sub F is equal to the normal force, and that's why we started with normal force, times mu. Now, you might be wondering, what are the units for mu? I'm sure you're all thinking about that. I'm sure you spend your days thinking about that. Mu. Okay, so I just changed these units from frictional force and normal force. Well, they're both in newtons. All forces is always in newtons. I'm going to show you why in a moment. But what's going to happen if you put the units in, they're going to cancel. So the friction coefficient has no unit, no type of unit. You just write the number. Say it's 0.25, just write 0.25, you're done. This is Newton's second law. Force is equal to mass times acceleration. Now, mass is in kilograms. Acceleration is in meters per second squared. And force is in newtons. So just so you know that newtons is equal to, I forgot the G here, kilograms times meter per second squared. I want to talk about the frictional coefficient, which is mu, and that's a measure of how much friction you're going to, that whatever body you're dragging across a surface is going to encounter. So let's think about this. The friction coefficient, which is going to lead to friction, is, and let's just say these both have the same normal force. And actually, let me go through this really quickly. This is called a free body diagram. When these problems get more complicated, then it's always good to write these. I would do it. You're less likely to make errors. I would just... So this is force. This is force due to gravity. This is the normal force. It pushes up. And again, F, the normal force is the same as the gravitational force pulling you down. Okay. And then this is the force pushing that way. We could say it's 15 newtons, 200 newtons. It doesn't make any difference. If this overcomes the frictional force, then it's going to move in the right direction, towards the right. But diagram A, we'll call it that. Diagram B, I just made that a rough floor. Don't think it's a raft floating on water. I got a C in art, and there's good reason for that. But the diagram on the left, diagram A, let's say it's just a rough surface. I don't know, sandpaper, a giant piece of sandpaper. You're trying to drag a block across that. It's going to have a higher friction coefficient. I drew that wrong. Okay. It's going to be higher here than if you're dragging the block on ice here in diagram B. So that's going to be a lower friction coefficient. So under normal conditions, your normal force is always going to be equal to your gravitational force, which is going to be equal to mg. So if you're given the mass and the gravity, well, you already know gravity, we're using 9.81 in this curriculum, and just multiply them together to get the normal force. You know, assuming everything is normal, nobody's floating, nobody's sinking. And know that the frictional force is equal to the normal force times the frictional coefficient. Okay, now we're going to look at some review questions, a box of mass 50. Well, actually, go ahead and pause the video. Try to solve these problems. After you solve them, push play, and then check to see if you got the solutions correct. Okay, here are the solutions to letters A and B, and letter C. Letter C, of course, it says, will the box move? Yes, it will move. Yes. And that's because 60 newtons is what's being applied. So 60 is greater than 58.9. So it's going to move in the direction that it's being pulled, because there's more force being pulled than that is resisting the body, whether it be a block or a dead body, or who knows. But whatever it is, this is always going to be the rule that if the force pulling it exceeds the frictional force, then it's going to move. If not, then it's not going to move. It's like pulling a car through a meter of snow. The friction is going to be much higher than the amount of force you're able to put on it, on the rope that's pulling the car. So you're not going to be able to pull it. But if you pull it on ice, for example, sure, you might be able to pull that car. So, because the amount of force you can put in the rope is going to exceed the frictional force.